So the example that I showed you before, this one, it is a single critic. Single critic means you just use one attribute for the critic. So critic on price means, okay, I will just define this threshold. There might be another critic, we call it compound critic. So compound critic means it is a critic over multiple properties that can improve the efficiency of the recommendation dialogues. Okay, I'm the user interest in this item. And the critics, there are two. The first critic based on price, and the second critic based on the megapixel. So it is the threshold for the item with the higher megapixel than the entry items are considered further. And this is the threshold. Items with a lower price than the entry items are considered further. Then, okay, this is the most similar item because it is lower price. Okay, it is lower price and it is higher on the megapixel. So because this is the compound critics, we can have dynamic critics. Dynamic critics, we can use a kind of method like association rule. So the association rule, this is the algorithm for the dynamic critic. The basic step for the dynamic critics is we need to set the queue. The queue means the initial set of requirements. So we can have the initial user query queue, and then we have the all the available items or CI, okay, the candidate items, and K means the maximum number of compound critics. So the number of compound critics per cycle K. And we have the minimum support values for calculated association rules. So if you still remember, in the first part of our lecture, we learned about the association rule. And for the association rule, we have support and confidence. So support means how many items are available in the transaction or in the list, and confidence, how big the confidence with regard to the item set. So this is the algorithm. And we will look at the item recommended and the user review, and based on the compound critics. And the compound critics that we want to look at is based on the minimum support. So for the single critic, we can see something like this. I want a higher resolution, single. So it means only one attribute. The compound critic means I want a higher resolution and a lower price. For the dynamic critic, it's more complicated. The camera resolution is too low. Is there any product with durable battery life? And I want a lower price. So this is common in the real life. So the user will give some critic on the recommendation items. Then, yeah, this kind of critic, it is very dynamic and it is based on some text like this one. So if it is a single critic, we can see that it is based on one attribute. It is not complex, the complexity is low, but the user flexibility is limited. For the compound critic, we can use multiple attributes, and then the complexity is moderate, and the user flexibility is more expressive. So they can express the more attributes to get the recommended items. For the dynamic critic, it is adaptive to user feedback. So for example, the camera resolution is too low. Then, okay, I know that the user wants to have a higher camera resolution. Or is there any product with durable battery life? Okay, then I know the user wants to have a good battery specification. And I want a lower price. Okay, I know that the price is too high for the customer. The complexity is high. It's very complex to understand this one. And it is flexible and also personalized. And we want to consider this more about the dynamic critics rather than the single critic and the compound critics. Yeah, I will not explain the calculation of the dynamic critic because it is uh, diverse, and then the concept of the association rule you have learned about the association rule before, so you can take a look on those example how we can use it for the recommendation system. So there are some examples here mentioned by the book authors about the recommendation system, how the financial services, it is about the sales dialogue of the financial services. So in the financial services domain, the sales representative do not know which services should be recommended. So at the first time, let's say you want to apply some loan, or you want to apply the education loan, or you want to apply for housing loan. Then at the first, you need the requirement. For example, how long for the loan, run time of the loan. And they might ask you about the personal data. And they want to know what is the purpose. Is it for the education, or is it for the housing? Is it for buying car? Is it for your investment, and etc. And how much you want to do the loan. So those kind of question will be the basic questions. So in the financial service domain, we need to also improve the productivity of sales representative, because there are many questions that they will ask you. Then yeah, you need to make it more efficient. So this resemble call center scripting. How we can look at the best practice sales dialogue. After, if it is everything true, then okay, we need to have the credit worthiness checking. If the credit worthiness checking, for example, the monthly rate, how big is the monthly rate that is good for the user? And what is the existing real estate that the user have? Who is the owner of the real estate, and what are the existing loans? So if everything is true, then we can give some product, or we call it product advisory and selection. And we have product A, product B, product C, and so on. After they have the requirement, after they have some idea about the product, and if it is true, then we do the calculation. We give the calculation and make a result from the presentation. So every of this one, it is this is the best practice sales dialogue. And there will be some steps, and there will be transition with predicates. So predicates is this one. Question. monthly rate. How big is the monthly rate? Who is the owner? Is there any existing loans? Yes, true. Is there any existing real estate? Yes, true. So if it is true, 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 and true, then we go to the next. So the research result from this example, yeah, it supports for knowledge acquisition. So this is the knowledge. It is the knowledge, the purpose, personal data, runtime of loan. And it requires the validation. The node properties, so this is the node, it should be reachable and it should be extensible and it should be deterministic. So reachable. So after we go this one, we need to go to this one. We need to go to this one and we need to go to this one. And then extensible, yeah, we can extend it. And deterministic. So it should be clear. We can have the answer yes or no. We can have the answer is this true or false. Or we can have the answer loan amount, yeah, more than 100 million Korean won or less than 100 million Korean won and etc. So it should be deterministic. This is another example. This is based on the sales support. In the sales support, it is very complicated because every customer, they will have their own product, their own critic, their own requirements, and yeah, the items and the variables will be very huge in the variations. So this is from one paper. It is based on the company Vita. It is a sales support, and it has a process. This is the first step. This is the second step. This is the third step, and then this is the fourth step. So in the first step, yeah, they have the recommendation process. They want to check the requirement. After they check the requirement, they want to check the credit worthiness check. So it's almost the same with the sales support in the previous one, but the financial, but it is only related to the sales. And at the end, yeah, we want to show the result presentation. So this is the requirement, like yeah, maybe it is in Germany, it's not easy. So what is the price and then what is the requirement, the credit and etc. And then they will have the recommendation item. So this is the product that has been recommended. And then there are some details and there are some reason why the product is recommended. So this is the requirement that has been articulated by the customer, and this is the result from the requirement from the users. And yeah, we can have this recommendation item as the solution for the customer with the requirement. This is another example. It is a critic in the restaurant. In restaurant, this is a restaurant in Vienna. This is also from one paper. So find your favorite restaurant. In Vienna, you can choose this restaurant. This is a restaurant with local cuisine. The price is between 30 until 50 euro. And this is the reason why the system recommend this one, because it is local food. It is in the central in the city. We can brunch provided, room with a view, famous for beer, seasonal dishes, group bookings, open all day. It means this kind of recommendation or this kind of lesson fit with the user requirements. For Grass, so it is another city. We recommend Brasov. The same, we have some reason. Local food, it is own beer, weekend lunch, open all day, private function room, and etc. So we can have some critic. This is critic. Do you need less money? Okay, then if you need less money, you can just click this one. Do you need a nicer environment? Okay, then you can click this one. Do you need about the cuisine or the cuisine is not good? Then you can click on this one. You need a place which is more quiet. Okay, you can click this one and so on. Okay, so this is one of the application. As we already learned, the critic, yeah, if you use the case-based knowledge-based recommender system, we can look at the similarity. So the similarity means we want to check the requirement and what are the items or what are the properties of these restaurants. So it is more complicated, okay, than the products like camera because the requirement is based on the user personal interest. Meanwhile, this kind of uh, qualitative, we call it the descriptive, okay, this kind of descriptive data, yeah, we need to extract maybe using text analytics, okay, using text mining. After we have the result, then we can do the recommendation. Yeah, this example, it is based on the approach of compound critics. It's more efficient navigation than with the unit critics. If we have the unit critics, it means only one attribute. And for the compound critics, we can mining the frequent items or the frequent patterns. If we use the dynamic critics, yeah, it is only applicable compound critics propose. The compound critics means more than one attribute. In some cases, there might be the incremental critics. The incremental critics, it is based on the history. So if you log in into one website, there will be some history. What restaurant that you have before? That kind of properties of the restaurant that you had before, it will be used for the recommendation in the future. So we call this is the incremental critics. Or we can have also another kind of suggestion or adaptive suggestion. It suggests items that allow to best define users' preference model. For example, yeah, there are some suggestion, private function room or famous for beer. So it is some adaptive suggestion which is not available in the critic. Oh, okay, then this is the summary. Yeah, so yeah, we learn about the knowledge-based recommender system. We know about the constraint base. The constraint base, we learn about the constraint satisfaction problem, how we leverage the constraint. We learn a little bit the conjunctive query without the query in the SQL and interacting with the recommender system. We learn about default. So whenever we have the knowledge, we can provide the default to the users. That is static, or it is dependent, or it is a derived default. And when the requirement is unsatisfied, when the requirement we cannot get the solution, so we can do the relaxation, or we can do repair, or we can do ranking. For a case base, we learn about the similarity measurement, and we also learn about critic, how the single critic works, the compound critic works, and the dynamic critic works. Okay, so some limitation of this knowledge base. We need to get knowledge from domain experts. It is not easy. Let's say if it is about a camera, yeah, you need to get the knowledge from the domain expert. Someone who knows about camera can give the knowledge. Or if you want to do the recommendation about car, of course you need to know the requirements from the car, and you need to get some knowledge from the domain expert about car. And we need to get some information from users. It is also maybe a tedious job, time consuming job. Or you need to get some knowledge from web resources. The limitation is the accuracy of preference models. The models that we provide can be very fine granular preference model. So if you want to make the very fine granular preference models, do you know what does it mean? Very fine granular. So in the computer science, we have two kinds of granularity. The first granularity is fine granularity. And the other granularity is we call coarse granularity. Fine means it is very detailed, very small detail. Coarse granularity. Coarse granularity means you can still have not all the detail, or maybe it is just roughly. So for example, the fine granularity. I want to recommend the smartphone and the price is 1 million won. Exactly 1 million won. Then it is very fine. But if it is coarse granularity, means I want to suggest a better smartphone. Nothing about value, nothing about specification, but it is only a better smartphone. So we call this is coarse granularity. So fine, we will make a very detailed, like the cost equals to a particular value, 1 million won, or the memory is very detailed. It is 12 gigabyte. Yeah, if you have this kind of very fine granular preference model, you need to have many interaction cycles. So you need to get conversation with the user more and more, because you cannot get the very fine granular preference from one time conversation. And it is a kind of collaborative filtering models preference implicitly. And the other limitation is independent assumption can be challenged. For example, the preferences are not always independent from each other. So yeah, those are the limitation when we use the knowledge-based recommender system. Okay, that's all that we can learn about the knowledge-based recommender system.